We're really excited to bring together unprecedented resources from speech-language pathology, audiology, and health and sport science to study aging. We're calling this the AU Aging Study. We're looking at the relationships between hearing, balance, and multisensory integration as people get older.
Well, as we age, the body goes through lots of different processes, and there's a real connection between the auditory system as well as the balance system and the way that the brain processes language or speech.
So we're looking at some clinical tests that may allow us to determine or predict someone who may be at risk of falling or may have balance decrements and how that may relate to their hearing function and their hearing perception.
In my lab, we use electroencephalography, also known as EEG. When the participant comes into the lab, we measure the circumference of their head to find the appropriate size net, and then we soak the net in an electrolyte solution. Once the net is soaked, we will place it on the participant's head and we will connect it to our signal amplifier. The signal amplifier allows us to read the electrical activity coming from the brain into our data acquisition computer. We design experiments to elicit specific cognitive and neural processes. When we design our experiments in a specific way, we can elicit what we call event-related potentials, which are neural signatures of brain responses. The neural signature that we're interested in for this study is called the mismatch negativity. The mismatch negativity is a robust effect of central auditory function and echoic memory trace for sound processing. It's commonly used with clinical populations because the participant can be sitting passively while sounds are being played in the background. We divert their attention to a silent movie so that we can say that the responses are pre-attentional. This takes out one of the confounds of an experiment. The mismatch negativity paradigm is called the oddball paradigm. In the oddball paradigm, you play a series of standard sounds that are on repeat. Then you intersperse that standard sound with a rare deviant sound. The response to the rare deviant sound shows that the participant can discriminate the difference between the two, and this creates the mismatch negativity response.
I do the hearing portion of the study. So subjects will come in and we'll put them in a sound-treated booth, and we will do a complete diagnostic audiological evaluation and do some speech and noise testing to see how they function in that type of environment. And from that, we can look at different patterns of aging in the auditory system.
For my portion of the study, we will have participants coming in, and then we'll go through a series of tests. The first test that we typically conduct is a hand grip test to gather some descriptive information in regards to their general strength. The next test that we would go through is called a timed up and go test. The individuals will be seated in a chair. They will be asked to stand up, walk 3 meters around a cone, come back and sit back down, and we time that task. With that same task, we will incorporate a cognitive component where we will ask the participant to continuously subtract a random number that is provided by the number 7 as they complete that timed up and go task. This is often really specific to neurological populations to assess their risk of falling. So we're adding what's called a dual task. So we're altering the individual's ability to focus on the motor task by trying to force their brain to have to think a little bit more and prioritize a cognitive task and a motor task. The last part of the assessment would be to look at their overall sway. We utilize our BioDeck sway machine, which we put the individual through 4 different conditions to assess their overall sway. These different conditions allow us to delineate which balance system may be impacted for that individual.
At the current stage of the research, we're looking at the relationships between hearing, balance, and multisensory integration via cognitive and linguistic neural processing. If we can establish these relationships in a large enough population of healthy older adults, we can use this information to design new and better treatments to support social communication and postural stability as adults continue to age.
I'm hoping that we're going to see some information that ties these systems together and maybe look at some patterns. And when we see these patterns, we can better understand how we age, the process of aging in these areas, And then that will enable us to really find good clinical solutions.
Ultimately, this research is imperative to build on future research. This project is foundational to help develop other projects where we can then focus on intervention.
We're hoping that the data that we collect in the early stages of this study can help us to design pre- and post measures for a future treatment study. We hope that this treatment study will improve quality of life for older adults.